The basic 6 flight instruments is made up of 3 pitot-static instruments and 3 gyroscopic instruments. In this video, we are going to be looking at the gyroscopic instruments that forms part of the basic 6 instruments. We'll start by looking at what is a gyro. A gyro is a rotating mass or a rotating wheel. A gyro rotates at high speed or high RPM in order for it to exhibit 2 characteristics of a gyroscope. The first characteristic is rigidity, and the second characteristic is precession. Rigidity is the ability of a gyro to maintain its spin axis or axis of rotation as long as the RPM of the gyro is kept high. So as we can see on this diagram, we have a gyro here. We have it's a vertical gyro. You can see the rotor, you can see the gimbal and the frame. As you notice, regardless of whatever is going on with the frame and the gimbal, the gyro maintains its orientation. It's not turning or drift or moving in any way. It's just rotating in around its plane of rotation. So this is what is called rigidity in space. And rigidity in space is affected by the speed of rotation. The higher the speed of rotation, the higher the rigidity in space of a gyro. The second characteristic of a gyro is precession. Precession is the ability or is the change of direction of the rotating axis of a rotating body due to an external force. And the change of direction takes place 90 degrees from the point of application of the force in the direction of rotation of the gyro. So as you can see in this diagram, if a force is applied at this, if a force is applied on this spin axis, and this is the plane of the force applied, this is the point of application on the gyro. The reaction will take place 90 degrees from the point of application in the direction of rotation. This arrow points the direction of rotation of the gyro. So a force is applied here and the reaction takes place 90 degrees from the point of application in the direction of rotation. So that is precession, which is the second characteristic of a gyro. We look at the 3 instruments that are found in the basic 6 that uses the gyroscopic principles. And the first one is the attitude and attitude direction indicator. This diagram, as you can see, this is our ADI, attitude direction indicator. First of all, I'll start with saying that an attitude direction indicator is used to indicate the pitch attitude of an aircraft and the roll or bank attitude of an aircraft. If an aircraft pitch, let's say 10 degrees up, you'll see this aircraft icon will actually the scale of the attitude indicator will move down up to the 10 degree mark will be in line with the aeroplane, and this will indicate a 10 degrees nose up. And the same will happen for a 10 degrees nose down. So that is how pitch is indicated on an attitude and direction indicator. The next indication that is found on an attitude direction indicator is roll altitude or bank attitude. And whenever an aircraft banks either to the left or to the right, this pointer here will move to the right or to the left, indicating the bank angle of an aircraft. Most of the instruments are graduated in 15 degrees, have 3 marks, 15 degrees, 30 degrees, and 45 marks, both to the left and to the right. Now, an attitude direction indicator uses a vertical gyro. A vertical gyro which has a vertical axis. The main characteristic of a gyroscope that is used in this instrument is rigidity in space. And this gyro has 3 degrees of freedom about its 3 axes. So let's see how the gyro works inside this instrument. This is a vertical gyro, and this is an instrument, and this is the instrument face. With the plane of rotation of the gyro passing through the gyro, it's horizontal with the instrument. As the aircraft pitches up, let's use the following picture. As the aircraft pitches up, the plane of rotation of the gyro, you see, it is maintained because this gyro uses rigidity in space, so it doesn't turn. Even if the aircraft turns or pitches up or down, the gyro will maintain its rigidity. And then the longitudinal axis of the aircraft, due to the pitch up of the pitching moment of the aircraft, the longitudinal axis will move up. So this difference in the plane of rotation of the gyro and the longitudinal axis of the aircraft is the pitching, is the pitch angle. The same will happen if the aircraft pitches down. The difference between the longitudinal axis of the aircraft and this plane of rotation of the gyro will indicate the degrees, the angle in degrees in which the aircraft is pitching up or pitching down. If it is, in the case of rolling, it uses the lateral axis, and the same, the gyro will still maintain its state, its orientation, and then the difference between the lateral axis and the plane of rotation of the gyro will be now the angle difference, be it 15 degrees or 30 degrees or 45 degrees, will be the bank angle that the aircraft is turning at. So that is the attitude and direction indicator, which is our first gyroscopic instrument. The second gyroscopic instrument is the horizontal situation indicator. Horizontal situation indicator is used to indicate the heading of an aircraft in relation to magnetic north. As the aircraft turns, this scale also turns with the aircraft, such that the heading of the aircraft will be pointed here on top of the instrument. So this instrument also uses a gyroscope, and this one uses a directional gyro, unlike the attitude direction indicator that uses a vertical gyro. Directional gyro has a horizontal spin axis. This gyro also has 3 degrees of freedom, and it also employs the rigidity in space characteristic of a gyroscope. So I'll quickly try to explain it, how the gyro works inside the instrument. This is our instrument, and this is the face of the instrument. This is our gyro and the spin axis. This is the plane of rotation of the gyro, and this one is the longitudinal axis of the aircraft. As the aircraft starts turning, the longitudinal axis of the aircraft will move, or will turn with the turn of the aircraft, and there, as a result, there will be a difference between the longitudinal axis and the plane of rotation of the gyro, and this will be the angle, the bearing that the aircraft is turning to. So this is basically how the horizontal situation indicator works. It also uses rigidity in space, like the attitude and direction indicator. Our final instrument that we are going to look at is the turn and slip indicator. Turn and slip indicator is used to show if the aircraft is turning to the left or to the right, using this pointer here. If it goes to the left, it shows the aircraft is turning to the left. If it turns to the right, it will point here, showing the aircraft is turning to the right. Turn and slip indicator also have an inclinometer here that shows if the aircraft is making a coordinated turn, or if the aircraft is slipping or skidding. If an aircraft is making a coordinated turn, this ball will remain in between these two marks. If the aircraft is slipping, let's say, for example, to the right, if the pointer is to the right and the ball goes to the right, this indicates that the aircraft is slipping. If the ball goes to the left, despite the pointer being on the right, this will indicate that the aircraft is skidding. And the same way happens to the left side. Now, a gyro that is used on a turn and slip indicator is called a rate gyro. And a rate gyro has 2 degrees of freedom. By this, it means it's restricted in one axis. It only has 2 axes. Now, let's see how this gyro works. This is the gyro. I want to point out that there are some springs inside the instruments, one on this side and one on this side, that whenever the aircraft is not turning, the springs pull the gyro back into this position. So whenever the gyro is displaced, the springs pull it back after the aircraft has finished turning to this original position. Let me use this picture here to explain what goes on. A turn and slip indicator, like I've said, it uses a rate gyro, and the main characteristic of a gyroscope that this indicator uses precession. Unlike the 2 instruments that we've seen that uses rigidity, this one uses precession. And from our definition, precession is a change of direction of the spin of the rotating axis, and it takes place 90 degrees from the point of application in the direction of rotation. So if a force is applied here, maybe due to a turn, a left turn or a right turn of the aircraft, the reaction will take place in the direction of rotation of the gyro, 90 degrees from the point of application. So if the force is applied here, the direction of rotation is this side, and then 90 degrees from this point will be this place. So this is where the reaction is taking place, and as you can see, it has tilted outwards due to this is the precession effect. Now the precession is affected by two things. The higher the force applied, the higher the precession. Second, the higher the rotating speed of the gyro, the lower the precession. So precession is basically directly proportional to the force applied and inversely proportional to the RPM of the gyro. So whenever an aircraft turns, a force is applied here. The reaction takes place 90 degrees from the point of application in the direction of rotation, and it tilts the gyro. After the turn is complete, the springs that I mentioned here pulls the gyro back to the position where it is supposed to be. So that is what that happens into this instrument. The 2 minutes that is written here means that for an aircraft to make it to 360 degrees, it will take 2 minutes. Reason being, for it to turn to this mark and to this mark, it uses 3 degrees per second rate of turn. So for it to make a complete 360 degrees turn, it will take 2 minutes, and that's why 2 minutes is mentioned here. So this is how our 6-pack look, or our basic 6 instrument: the airspeed indicator, the altimeter, and the VSI that we looked in our previous video, and the 3 instruments: ADI, HSI, and turn and slip indicator, or in this case a turn coordinator that we've seen in this video. I hope you've understood. If you haven't subscribed to the channel, don't forget to subscribe, like the video, and also share with your friends, and turn on also notifications so that whenever we put a new video, you'll always be notified. Thank you.